Alright, this is 2.1 part 2. We're going to start at example 7. We already did up through example 6. Example 7. For the function f defined by f of x equals 2x squared minus 3x, evaluate the following. Okay, so if you look down here, basically what you're going to do is you're going to plug in whatever number's in the parentheses. So for this one, you would have 2 times 3 squared minus 3 times 3. 3 squared is 9. 2 times 9 is 18. 3 times 3 is 9. 18 minus 9 is 9. So that would be the answer for the first one. Same thing here. We would start with, if you just plug in x, you have 2x squared minus 3x. That's the first. That's just this one here. This one would be, well, 9. So 2x squared minus 3x plus 9. And then I got the 9 from up here. Okay. Now, if you're multiplying a constant into the function, let's see here, you're just going to distribute it. So I've got 3 times 2x squared minus 3x. If I distribute the 3, I've got 6x squared minus 9x. There we go. If I plug in a negative x, 2 times negative x squared minus 3 times negative x, this gives me 2x squared plus 3x. And I'm not sure why I didn't leave as much space here. I think that's a mistake. But if the negative is outside, then you multiply just the same way you multiplied the 3. So I've got negative 2x squared plus 3x. For this one, 2 times 3x squared minus 3 times 3x. Remember, if you're squaring everything in the parentheses, you have to square both terms. So I've got 2 times 9x squared minus 9x. This is 18x squared minus 9x. Alright, this one's going to be a little bit tricky. We've got 2 times x plus 3 squared, minus 3 times x plus 3. The second term is not so hard, but the first term might be a little bit tricky. We need to FOIL this. If you guys remember, when you FOIL a perfect square, you're going to get x squared plus 6x plus 9. Basically, the first term squared plus 2 times these two terms multiplied together plus the second term squared. And then we have the second term, minus 3x minus 9. So I'm going to distribute the 2. I've got 2x squared plus 12x plus 18 minus 3x minus 9. And now I'm going to combine like terms. So I've got 2x squared, 12x minus 3x is 9x. 18 minus 9 is 9. Alright, here we go. X plus h minus f of x. So now we've got 2 times x plus h squared minus 3 times x plus h minus 2x squared minus 3x. And make sure that negative is multiplied by everything in here. So what I'm going to do here is I am going to simplify and combine like terms. Once again, a perfect square. So we've got 2 times x squared plus 2xh plus h squared. I'm going to distribute the negative 3 here. So I've got minus 3x minus h, 3h. This is an invisible -1, so I'm going to distribute that here. I've got minus 2x squared plus 3x. And the whole thing is over h. Now distribute the 2. 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x. Alright, let's combine like terms. 2x squared minus 2x squared. This goes away. Whoop, I forgot the over h, sorry. Negative 3x plus 3x, those go away. So I'm left with 4xh plus 2h squared minus 3h over h. Now each of these terms has an h in it, so I'm going to pull out an h. So I can cancel it out. So 4x plus 2h minus 3. Done. I think that's the toughest one of the bunch. Alright, you guys go ahead and try these you-try problems. Hopefully you guys can get those. Alright, let's pull out a calculator. Alright, here we go. F of x equals x squared. So 1.234 squared is that. 1.52, I'm going to round to 4 decimals. So 1.5228. 1.5228 approximately. Alright. Next one. 1 over x. In this case, x is the same. 1 divided by 1.234. 0.8104. 0.8104. Alright, and the last one. Square root of x. Square root of 1.23. Oop, my bad. 1.234. There we go. So 1.1109.
Yeah.
1.1109. Okay, so these are all approximations. Notice how in each of these problems, I just took this and I plugged it in for x. That's all you want to do. Whatever's in the parentheses, that's what you plug into your variable. Alright, so important facts about functions. Okay, I'm going to write these out and then I will talk about it. Alright, for each x in the domain of a function f, there is exactly one image f of x in the range. However, an element in the range can result from more than one x in the domain. So for example, if you have a bunch of x's and a bunch of y's, you can't have one x correspond with more than one y. Okay? But you can have more than one x correspond with the same y. This is okay. But if this x were going to this y, going to two different y's, that would not be okay. Okay. Alright. F is the symbol that we use to denote the function. It is symbolic of the equation that we use to get from an x in the domain to f of x in the range. Okay, so if I say f of x equals some equation, from then on, everywhere you see an f, f represents a full equation. It's not just one number, it's not just one variable, it actually is a whole thing.